Hello everyone, Ismail is here. Today we're going to study the lesson 15.5 angle bisectors of triangles. Angle bisectors of triangles, it's easy lesson. It's similar to the 15.4 that we learned before, which is the perpendicular bisector. You can find the lessons or them on my website alfarramar.com. Now, this is a warm-up question. I need all of you to start solving it. But to remind you with 15.4, because this one is a question from 15.4, we know that before we start solving the question, we learned that from 15.4 that if I have a triangle, okay, and this triangle has a circumcenter, so this point here called circumcenter, okay. So if the question has a circumcenter, we know that the length is from the starting point to the every vertices. All of these sides should be equal, okay. So we know that, let's say this is B, this is A, okay, this is B, this is C. So now we know that BA is equal to BB is equal to BC, okay. But let's say if we do the same triangle here and we have the same thing, let's say this is A, not B, okay, this is A, B, C, and this one is B. But if we do the perpendicular bisector, which is this one here, and this one here, so now these three sides, let's say this is X, this is Y, this is Z. So now here BX is not equal to BZ, is not equal to BY, okay. So all of these are not equal. So this one, when we have the question, give me that it's circumcenter or it's saying perpendicular bisector. If it's perpendicular bisector, okay, or a circumcenter, so the triangle has the side from the circumcenter to every side here, every vertices, so the sides are equal. And the perpendicular bisector, these are sides, they are not equal, okay. Now let's solve this question here. Suppose that ZB is equal 145. So this one here is 145. So ZB from Z to B is 145. Now which side represent also 145? So also we know that ZC is 145. Also we know that from Z to A also 145, okay, because this center here, which is Z, is represent the circumcenter, okay. Now what we know, then what we have also another information, we have ZD. So ZD is equal 100. Where is ZD? So from here to there, this one is equal 100, okay. Can I say ZF is equal 100 or Z equal 100? No, I can't, because as I told you here, if the angles are bisectors, this one here, they are not, okay, they are not equal, okay, so they are not equal. So only the equal side if it's to the vertices. Now let's continue. So the question said ZF, okay, so ZF here is equal 70. Where is ZF? ZF here is equal 70. Now how can I solve this equation? Find AB and AC. So as you can see here, he needs me to find this all measures, okay. I know that this side here from A to D, okay, from A to D, this one A to D, it's equal from B to D, right? Because this one here, it's perpendicular bisector, as I told you here, okay. This side here is equal to this side here, and also this side here is equal to this side here. Also this side here is equal to this side here, okay. So now for sure AD should equal to BD. So now if I find AD or if I find BD, I can multiply by 2 to find the total length. Now how can I find this length here? Now if I take this rectangle, okay, if I take this rectangle, let me show it to you, okay. If I take this rectangle from this side here and this one here, okay, can I use this rectangle to find the answer? Yes, I can use it. Let me draw it here again for you. So this one here like this, and should be something like that, right? So this one here is right triangle. This side here is equal 100. This side here is equal 145. This side here is AD, which is that I need to find. Now, if you remember, we can use the Pythagorean theorem, and the Pythagorean theorem, it's saying C square equal A square plus B square. We know that the C represents the hypotenuse. How do I know the hypotenuse? Okay, hypotenuse, okay, always opposite, okay, to right angle, okay, right angle. So hypotenuse, how do I know the hypotenuse side? So hypotenuse side, okay, hypotenuse side is always opposite to the right angle. So which side here is opposite to the right angle? This is the right, so this one is the hypotenuse. So now this one here represents C. So now let's put the number. So C is equal 145 square equal 100. It doesn't matter if you write 100 as A or B, no different. So let me write it as A square plus B square, which is that I need to find as 80, right? So B square is represent the 80. Now solve this equation. Now the 100 square means 10. It's, if you do it in the calculator, it will give you 10,000 plus B square equal 145 square. It's equal 21,025. Now what we have to do, we have to minus 10,000 from both sides. 10,000 minus 10,000. Okay, so we cancel these out. So B square, it's equal 21,000, okay, minus 10,000, which is equal 11,000 and 25. Now what should I do? What do you think should I do here? I have to do square root for this, for both sides. So square root for 11,025, which is equal B squared, sorry, B, we remove the square now. So the square cancel the square root. So B is equal 105. So now here B, which is represent AD, 105. And as I told you, AD here is equal 105, right? So if this 105, okay, 105 times 2 to find the AC, okay? So now AD is 105, BD is 105. Let me erase this one. Okay, so now the total from A to B, okay, from A to B, it's equal 105 times 2, or 105 plus 105, which is equal 210. Okay, I hope you understand that. So this one is 210. Okay, now let's do the AC. So the same thing with the AC, if you want, if you need to know. So now we need to find AC from here to here. So in order to find AC, you have to do the same thing. Just pick one of the triangle. So just example, you can take this triangle here. Okay, so as you can see, you can just take this triangle and draw this triangle again. Okay, then do the same step. This is right angle, this is 145, this one here is equal 17, this one here is A, okay, or B, it's up to you. Then now use the Pythagorean theorem. So this side here from CF, okay, it should equal to the side AF. So the final answer, which is AC, equal AF plus CF. Then you can find AC by first using Pythagorean to find B here, sorry. Okay, I hope you understand this for this one of the question. Now if you have any question, please contact me. Now what is the lesson angle bisector theorem here? So what is the angle bisector? First, before we go the angle bisector, we need just to memorize what we learned in 15.4. Okay, so 15.4, how we can use the perpendicular bisector to find the point that equidistant. We learned that how we can find this point here, which is represented by the equidistant, using the perpendicular bisector. Means this one here, if we connect the line, so this side here is equal to this side here. If I connect a line from here, so this side here is equal to that side here. If I connect a perpendicular bisector, so this side here is equal to this side here. Okay, now if the angle bisector, how can we use angle bisector to find the point? Okay, let me remind you. So the perpendicular bisector, so I have a ray or a line. okay, and I have a line intersects, so this one by perpendicular, so this side here is equal to that side here, okay. So from here to here it's equal from here to here, so if this one 5, this one should be 5, so this is perpendicular bisector. But here it's saying angle bisector. So what do you think is angle bisector means? If I have an angle like this, and let's say the total angle is 100, so angle bisector means I'm talking about if the angle comes in the middle, so that's mean this one here should be 50 and here should be 50. So that's the meaning of angle bisector. Means if I have a triangle, same thing of a triangle here, so if I draw now a straight line from this one here, so this angle here, if this one's 6, this one here should also equal 6. If I go straight line here, angle bisector, if this one, let's say 70, this one here should be also 70. Okay, same thing here. If I go to the other side, if this one here is 30, this one here should be also 30. So this what we call angle bisector. Okay, and here it's perpendicular bisector, which is this line here is equal to that line here. So if this one 6, this one should be 6. Same thing here, if you go perpendicular, so this one here is equal to that one here. So if this one 7, this one should be 7. Same thing here, if this one 8, this one should be 8. Okay, but here the side, as you can see, they are not equal. There is no equal side. It's just one whole side. There is no equal. Here we are talking about what? We're talking about the angle. The angle are equal. Okay, I hope you understand this. Now let's go some through of the theorem here. So the angle bisector of the triangles. Now a circle is inscribed in a polygon of each side of the polygon is tangent the circle. So we call the circle that here is touching, okay, because tangent means touching. Okay, so touch the circle from each side, touching from here and from here and from here. Okay, so we call this one inscribed a polygon. Now in the figure here, circle C is inscribed in a quad WXYZ, and the circle is called in circle of the quad C is the code in center. So in the previous lesson we call the C here circumcenter, but here we call it in center. Okay, or sometimes in center, or sometimes we call it in circle. So it's up to you. In center or in circle, same meaning. Now to find the in center of a triangle, construct the bisector. Now let's construct the triangle using the construction tool or the geometry set. First thing, to construct the angle, first just draw a small triangle. So let me AQ triangle. So let me draw any AQ triangle. Okay, we just connect it like this. Sorry, let me erase this triangle here. So let's say from this one to this one here. Now this is a triangle. Now what you should to do, just take your compass. Let me change the color. Take your nail, put it on one of the edges. Now open your compass at any point, anything. It's here or there. It's up to you. It's fine, and it's just anywhere. So I will just open it here. Okay, and lock your compass. Then draw a small arc. So your arc should intersect your triangle with 2 points. So how many points do I have here? So I have 2 points. This one here, sorry. This point here, okay, and this point here. So as you can see here, I have 2 points that I intersect. Now take your compass, put it on the first intersect, and okay, open your compass, okay, more than the triangle like this. Okay, now make a small arc like this. Okay, just make a small arc with the same opening. Don't change the opening. Take your ruler, put it on the other intersect that we made it here. Okay, now draw another arc. So as you can see, they are intersecting to each other. Now take your ruler, okay, use your ruler, connect between them from this side here to that one there. Okay, so this is the first step. Now apply the same step to the other side, to the other angle here. So do you see this angle here? You have to apply now. So now take your compass, put your compass at this side. Okay, now as I told you, open your compass anywhere on your line. Okay, so I will just open my compass here. Now look your compass, draw a small arc. So now we are creating how many intersects? Also we are creating two intersects. The first intersect is here in the red color. The second intersect is here in the second color. Now take your compass, put it on the first intersect that we made it here. Okay. Okay, put your needle. Now open your compass anywhere, somewhere here. Now draw your arc. Okay, so this is your first arc. Now with the same opening, put it on the other point. Okay, and draw another point. So as you can see, now we are creating a new intersect. Now take your ruler. Okay, connect between the point. Connect between the point between this one and this one like this. Okay, now I have an intersect point. Okay, here if you look, I have intersecting point here in this. Okay, so what I have to do in this side here, I have now to take my compass. Okay, now take your compass, put your compass at this intersecting point. So the needle, I'm talking about the needle, just put your needle here. Then take your compass, okay, open your compass to one of your line. Okay, so just open it to the red or to the blue. Do you see red or blue? Red or blue. So I will open just for the red. Now close this one, make your circle. Just make your full circle. So do you see now my circle is touching, okay, my triangle from all the sides. Okay, so this one here is touching from all the sides, so that's mean, okay, from this one to this one here, this one should equal to this one here, also should equal to this one here. So as you can see, this one is equal to that one here, is equal to that one here. So this is how we can prove this one.